All right, guys, welcome back. We are closing up the spanning tree section. When we left off at, we were talking about rapid spanning tree, right? The enhanced version of regular spanning tree that knocks it down roughly 20 seconds. So the total time of convergence for regular spanning tree is 50 seconds. With rapid spanning tree and the enhancements, it's been knocked down to just 30 seconds, right? But we can talk theory all day, every day, right? But I want you guys to actually see what's happening on the device, right? So you guys get into the field, and you guys, begin to, think about spanning tree when you're taking the CCNA. You guys be able to work through in your head what's actually happening through the little bit electronics on the device, right? You know what the brain of the device is doing, right? So let's go ahead, right? Let's talk about this topology. So got three switches, right? Don't really need two. We could have had two, because the core theory is what, right? Is to create a loop-free topology with redundant connections, right? So we could have done it with two and have redundant connections there, but my favorite is always three, right? So we have switch one, switch two, and switch three. Switch one having the lowest MAC address, right? And I'm gonna say all these for refreshers, right? So it having the lowest MAC address, and none of the priorities on each switch were modified. So switch one will win the election process for a root, right? And of course, switch two and switch three, right? Switch two being the second best, switch three being the last best, right? Switch two is going to win the election for the designated switch, right? And of course, the switch tree is going to be the non-designated switch, okay? Whenever I get these connections. But again, what happens in the background, okay? So let's go ahead and pop into a CLI. Uh-oh, went to my other screen. Sorry, folks. There we go. All right, so we're here, right? We're in the CLI. Let's go ahead and do a debug of spanning tree. But first, right, before we do anything, let's see what version of spanning tree the switch is running, right? Because by default, right, all switches out of the box are running just regular spanning tree, right? How can you tell, right? Well, if you read your book and you see the screenshots, Cisco Press, right, the people who make the book, publish a book, they actually get an excerpt from the CLI and show you, right, the telltale difference, right? So seeing IEEE, right, tells you that it is running regular STP mode, right? So what we need to do, right, because the topic of discussion is rapid spanning tree, we need to go ahead and change this, okay? And you will need to know how to identify the difference between if a switch is running regular spanning tree or rapid spanning tree or a different mode in the CLI, okay? So let's go ahead and make that change. So spanning tree, right? We're going to use the question mark because, of course, we don't memorize commands. We're going to go to mode, right? And it gives us options, right? We have per VLAN spanning tree mode. We have multiple spanning tree. Of course, for my people that's studying for their CCNP, that's one of my favorite modes of spanning tree. And of course, rapid spanning tree, rapid PBST. So we're going to do rapid PBST. So we're going to put it there, right? There we go. All right, so we switched it. Okay, now let's go ahead and check it. And we're gonna have to do this for all of our switches. There we go. So now it is running RSTP. Okay. All right. And so of course, like I told you guys, if we go to each switch, it's going to tell us that it itself is the root because of course it hasn't communicated with anybody, right? So it thinks that, hey, I'm king and I have the lowest bridge ID in this topology right now, even though it's not connected to anything. Okay. If we go to switch two and switch three, just like I shared with you guys before, it's going to have the same thing, right? So let's go ahead and take care of switching the whole topology to rapid spanning tree before we get everything connected, okay? So we're gonna go ahead and do this on switch two. All right. Do that. There we go. All right. Right. Even though we just configured it, right? My favorite saying from one of my favorite mentors is trust but verify. We are going to do the command anyway to verify it, right? And it is running spanning tree. All right, let's do it on switch 3, right? All right, so let's go ahead and go to configuration mode, global configuration mode. Let's go ahead and make a change to the entire switch, right? There we go. All right, save our config, right? And let's go ahead and trust but verify. So span tree. There we go. All right. So we have that all set, right? So what we're going to do, right? We're going to go ahead and see how this process works. Because of course, right, it's protocols like spanning tree, LACP, some protocols that run at layer 3 like OSPF, egrep, um, VIRP, all of these operate at milliseconds, right? And sometimes too quick for even a human eyes to go ahead and capture, right? But I'm going to go ahead and enable what they call debugging, right, for spanning tree, so we can go ahead and see some events that are happening, and we can see some of the things that some of the port roles that'll be changing, some of the state changes or what have you, just so we can talk about it, we can start having conversation about it, and all of it can go ahead and come and make sense. So let's go ahead and clean up the terminal, right? And let's do a debug, right? And we're going to question mark it out, right? We have all these options. What we're looking for is spanning tree, right? So we're going to have to hold space bar for a while. Imagine if it was just enter. Oh my goodness. It's been line by line. All right. Okay. Perfect. All right. So there we go. Debug spanning tree. All right. And we're just looking for events. So we're just going to go ahead and do events. All right. So we're going to do that here, right? We're going to do the same thing on other switches. All right. Let's go ahead and clear it up. Now, while I'm doing this, I got some time to talk. Now, if you guys have never watched Spider-Man, right? Peter Parker's uncle tells him the greatest quote in the world, right? With great power comes great responsibility. This debug command is a very powerful command. You really want to know what you're looking for and what you're doing before you even configure it on any device, not just Cisco devices, on any devices. Reason being is, the debugging, feature, it utilizes the CPU, right? And the entire box, all of its functions, it relies on the CPU. And if you utilize that too much, right, by forcing right debug mode to send out messages and to track, right, and to monitor all these functions that happen in the background without log messages being sent, you can, right, if ran during the production environment, or of course not even during maintenance hours, you can actually take down an environment because the switch will be unavailable because it's running too many functions. So you really want to know what you're doing, right? What you're looking for, right? With this debug command, and make it very, very specific. Okay. All right. So now that we got that settled, right, and we went ahead and enabled it on all the devices, let's go ahead and reset. There we go. And let's start getting some things plugged up. Well, let's see what happens. All right, so let's go ahead and plug this up. And what we'll do as well, we can do this. I'm going to do a packet capture as well. We'll start those packet captures. Maybe it'll capture, maybe it'll not. Typically, something has to be connected for EVNG. I'm going to go ahead and start it just in case if we get something connected. There we go. All right. All right. So let's have these run in the background. One is interface 0, one is interface 1. So let's have these running in the background, and let's plug one up to switch 2. All right. Let's confirm that. All right. No changes just yet. Oh, there we go. All right. And let's go ahead and take a look. Ah, there we go. All right. And so now we're getting some messages populating, right? And we'll talk about this in a moment, right? We'll talk about it and we will go ahead and plug everything else up. Okay. All right. Plug everything else up. All right. And what I'm going to do as well, I'm actually going to capture on gigabit 0/1, right? So I can capture what's happening on this segment between switch 2 and switch 3. So let's go ahead and do that. There we go. All right, we have traffic. Perfect. All right. So, and just for good measure, let's go ahead and capture here as well. By the way, guys, Wireshark is an amazing tool to go ahead and understand, to try to go ahead and understand what some of these things are, some of these protocols, how it works, and how it looks on the wire, right? Just so you can better understand, network engineering at its core, right? So let's go ahead and get these connected, all right? Let's go ahead and straighten it up a little bit. All right, so now we got these connected. Yeah, that's a little straightened. All right, so now, so we got switch 1, right? Switch 1 is good to go, right? It is, not many messages popping up, right? And we have switch 2, right? Populating, right? And we see a lot of messages for switch 2. We'll talk about it for a moment, right? We will talk about it in a moment. Let's go ahead and go to switch 3. Let's take a look at how that looks. Okay, right? And there's other great things that populate right here. So we're going to take a look at this. Let's go ahead and begin to go ahead and break this down. All right. So first things first, all right? Let's go ahead and do a show spanning tree. Okay. Right. So as expected, right? Just like I told you guys, let's take a look at a few things, right? So we realize, right, the root is this switch, right? How can we tell, right? Just a refresher. The root ID, of course, is 5000.01.00, right? Right? And this is just telling us what the root is, right? This is going to be on every switch. But the bridge ID is this switch using this command, right? And so if we take a look at this, this matches this. So context clues, it tells us, hey, this switch is the root, right? And this also tells us, right, this bridge is the root, right? So we have that set, right? And of course, like I stated with you guys, we did not manipulate the priority, right? And the priority value by default, you guys need to know this for your exam, is 32768, right? The priority for each VLAN is going to change, right? Depending on the number of the VLAN, right? So the priority is going to be the default priority number plus whatever the number is of that VLAN. So if I have a VLAN 1, it's going to be 32768 plus 1, which makes it what? 32769. If I had VLAN 2, it'll be 32771. Okay? All right. And so we spoke about port roles and port states, right? So since it is the root switch, refresher, right? The root switch, it is that point of exit and entry. Okay, so all of its ports needs to be forwarding, right? They all need to be available, right? As you guys can see, the port role is set to designated, right? That's always going to be on the root switch. All of its ports are going to be designated, right? And the state is going to be forwarding. It always needs to be available to go ahead and pass frames throughout its ports, okay? Let's go ahead and go to switch 2, all right? All right, so we're at switch 2. Let's go ahead, and we're going to come back up to the debug messages. Let's do a show spanning tree. Perfect. And while we're waiting, let's go ahead and stop the packet captures. We will come back and take a look at that. Stop the packet captures. Let's go ahead and stop the packet captures. And let's go ahead, right? Switch 2, right? So we're looking at another show spanning tree command, right? So we know the root ID, right? We had communication, right, with the root, right, which is switch 1, right? Okay. We know the cost to get to the root, right, which is 4, and because we went over cost before, and we know what port connects to the root, right? Sometimes it won't be physically, right, how you connect to the root as far as, oh, it's I may be connected to another switch, but that's not the actual root of the entire topology. It may just be the next switch up that's connected to that root, okay? But and in this case, we're directly connected. We have a cost of 4, right? The lower cost always wins. So it chose gigabit 0/0 has the interface to take the path to get to the root, right? And what does that mean, right? Gigabit 0/0 is what? It has the role of the root port, right? And it needs to be 40, okay? All right, and so same as always, like I told you guys, right? Priority has not been changed. 32,768 plus the VLAN ID, aka sys ID extension, right? Which is 1, which means VLAN. It's going to be 32,769. Okay, and here's the MAC address of this switch, right? This is our information, right? This is our bridge ID. Okay, MAC address plus the priority. All right, so we have, of course, gigabit 0/0, right, which is the root, right, has the root port, and we have all the other ports that are designated ports. So we have no ports that are blocking, right? So our theory, right, my theory that I stated that this is going to be the designated switch, right? This is the next switch running up, right, to be the root. But also, this is the switch between switch 2 and switch 3 that had a lower value, right? Lower value to go ahead and reach the root, and also had a lower bridge ID between itself and switch 3, right? So that's why it was selected to be the designated switch. Okay, so all of its ports needs to be in a forwarding state, right? And of course, its root port needs to be in a forwarding state. Okay, let's go ahead and check switch 3. Good old switch 3. So if we do the same command, show spanning tree, right? We see a few things, right? We see a few things similar to what we've seen in regular spanning tree, right? So we have communication with our root, right? It's telling us who the root is, right? Which is switch 1. So we're good there, right? We know what port, which is the root port, which is gigabit 0/0, right? Cost of 4 to get there, right? Lowest cost always wins, okay? Right? And we can see our information, right? You see our bridge ID, right? 32,769 along with, right, our system MAC address, right? That is our bridge ID, right? So we're looking good, right? Let's go down to the interfaces, right? So we have some interfaces that are forwarding, but let's take a look at the first two, right? So we have our root port, which is gigabit 0/0, right? Cost of 4. But we also have a gigabit 0/1, which connects to switch 2. That is the alternate port, right? In the regular spanning tree, it would be the right. It'll be a different port, right? It'll be the blocking port, right? It wouldn't be an alternate, right? And what do we say with the alternate port, Russ? The alternate port is the port that replaces the root port when the root port fails. Okay. So if, of course, gigabit 0/1 goes down out of nowhere, immediately, right? Or as my niece says, immediately, the alternate port is going to become the root port. Okay, right? But while the alternate port has its current role, right? So gigabit 0/1, right? We don't want to go ahead and create a loop, right? We do not want to create a loop. So we want to go ahead and make sure we are not passing traffic through that port, right? But it is on standby, okay? So that alternate port needs to be in a blocking state, right? So it's not receiving any packets, any BPDUs, et cetera, okay? So that is the review, right? That is a review. Of course, we can go ahead and expand this, and I want to expand this so you guys can actually see the different states with RSTP, right? So what are we going to do? Let's go ahead and add, right? Let's go ahead and add another port, right? Let's go ahead and connect this up, right? And let's go ahead and add another port, right? We're going to muddy up this topology, right? Okay, let's go ahead and add up another port, all right? Let's go ahead and switch one. All right, perfect, right? So we have all that. We're going to check our spanning tree entries in a bit, right? So we have to switch one. Let's go to switch two. We see a few things, and we're going to come back. I haven't forgot. We're going to come back to these debug logs. Okay. All right. And let's go ahead. There we go. There we go. There we go. All right. Let's go ahead. Let's take a look at that. All right. So let's first look at switch one, right? All right. Switch one, same rule I told you. It's the root. All of its ports are going to be in a forwarding state. So no, there's not going to be no changes to the role or the states whenever there is a new connection. Okay. So we can go ahead and minimize this, right? Let's go ahead and take a look at the designated switch of our topology, which is switch two, right? And let's run another show spanning tree so it's fresh. Okay. So we have a few ports that are connected. We got gigabit 0/0, we have gigabit 0/1, we got gigabit 0/2, and we got gigabit 0/3. The odd numbers are connected to switch three. The even numbers, right, 0 and 2, sort of say, are connected to 1, right? So let's look at 0, right, first. That's our root port, right? That's connected. That's all good, right? Then we have our, gigabit 0/1 that's connected directly to switch three, right? That's in a forwarding state, right? That's in a forwarding state. And we'll come back to that, right? Then we have gigabit 0/2. That is the alternate, right? That is our new alternate. Okay. Gigabit 0/2 didn't have an alternate before. Now it does, right? And this is just our backup for the root port. So backup for gigabit 0/0. Now we're looking at gigabit 0/3, right? It is designated, right? And so one of these are our backup ports. Okay. Let's go to switch three. Let's go ahead and take a look over there. Okay. All right. So gigabit 0 and gigabit 2 is connected to switch one, right? Even numbers are up there. Gigabit 1 and gigabit 3 connected to switch 2. So let's take a look, right? Gigabit 0/0, that is our root port, right? It's good to go. It's working well, right? And so if we look at gigabit 0/1, that is in a alternate state, right? It's blocking, right? If we go to gigabit 0/2, that is also blocking, right? In an alternate state, an alternate being a backup to the root. If we look at gigabit 0/3, that is also in an alternate state, right? why are these all in the same state, right? Well, of course, this is the non-designated switch, but, right, we cannot have two paths to the root. We just cannot. We just cannot that are active, right? So we need to go ahead and make sure we block off one, right? And gigabit, right? And I'm sorry, and switch 2 is the designated switch. So switch 3 lost the election. So it's going to block all of its ports that connect to one switch 2, and of course, one of its other ports to switch 1. But that doesn't explain from a technical standpoint why it didn't choose any of these other ports that connect, right? We get gigabit 0/1 and 0/3, right? The cost of each gigabit interface is 4. To get to the root, right, would be a total of 8, right? If it goes through switch 2. But gigabit 0/0 and gigabit 0/2 have the same cost. So why was gigabit 0/0 selected and not gigabit 0/1? Well, if you look back, right, at your elections, right, election process of choosing the root port, right, you'll see, right, that election process didn't change, right? It's the same as it is in STP, as it is in RSTP, right? And so first we're going to go ahead and look at a few things, right? We're going to go ahead and look at, hey, what's the cost, right? Who has the lower cost? We're going to go ahead and look at that cost. And then when we look at the cost, right, we're going to look at something what we talked about, and of course, that I didn't show you in spanning tree, but I'm going to show you in RSTP, which is priority number, right? We're going for the lowest priority number, okay? That's our tiebreaker. That is our absolute tiebreaker. And just as a review, right, I'm going to go ahead and go through the tiebreaker to choose a root port, right? And so, give me 1 second, right? So with that, right, let's talk about how to choose a root port, right? Choosing each root port, we're going to start off first, like you guys always know, the lowest bridge ID, right? Who has the lowest bridge ID, right? Switch 3 is looking at, switch 1 and switch 2. Oh, switch 1 has the lowest. Boom. We're going to choose that one, right? I'm going to go ahead and choose that. That's my bridge ID, right? But now gigabit 0 and gigabit 2 are both connected to switch 1, right? So we both know that it has the lower bridge ID off of 2 ports. What's next? Choose the port with the lowest port priority. Okay? That's your priority number, right? So 128.1, right, is gigabit 0/0, and gigabit 0/2 has a port priority of 128.3. Who wins that fight? Gigabit 0/0. That's how that election is made. You will need to know this for the exam. Okay? All right? And that is the reason why internally the switch said, hey, you have a lower priority number, right? We've learned the bridge ID, right, the same way, but you have a lower priority number. I'm going to go ahead and use gigabit 0/0. Okay? Right? So I'm going to set gigabit 0/2 into a blocking state. It's going to be an alternate, right? Just in case I need a backup. And the reason being is because, again, gigabit 0/2 lost the tiebreaker and it has a lower priority number, right? So it's going to be a backup root port, right? Gigabit, of course, 1 and gigabit 0/3, it could be another alternate as well, okay? Of course, everything else can be a backup port, okay? So that is rapid spanning tree, right? I want to go ahead and take a look at these messages, right? I want to go ahead and dive in, right? So let me go ahead and go back to switch 2. Switch 2 actually showed us tons of information, right? So if we talked about the spanning tree process, right? As soon as we're connected, right? You guys can see, right? You guys can see the communication, right? Interface 0/0, which of course is our initial connection to switch 1. It came up, right? So BPDUs are set, right? BPDUs are set between the switch, right? And what it's now saying is that, hey, with spanning tree, I updated the roles of the ports, right? I received a superior BPDU on gigabit 0/0, right? And what consists of a BPDU? Which of course it has that bridge ID. In that bridge ID, it has the priority number and the MAC address of the entire device, right? And looking at the MAC address for switch 1, it is lower, which is of course superior than switch 2, right? And so now the switch did its own math, it calculated, it computed and said, hey, I'm going to go ahead and set gigabit 0/0 has the root port, right? And now that I've selected my root port, I'm going to go ahead and set all of my ports, right, to be in a forwarding state and to sync with gigabit 0/0 to listen, right, to that port, because this is the root port, okay? This is what signifies and tells the other ports that this is a root, okay? All right, so what is it doing next, right? It's generating a TC trap for port gigabit 0/0. We haven't talked about traps yet, right? Or topology changes, right? Because this is one big thing we need to look at for troubleshooting, and we'll talk about that in the next chapter. But whenever topology change happens, right, a trap is basically a notification, right? It is letting a source or destination know, right, that a change has happened, right? And so what this switch is doing, right, switch 2 is saying, hey, there's been a topology change, okay? Roughly 1 millisecond after I went ahead and, set gigabit 0/0 has the root port. I'm sorry, roughly 10 milliseconds after, or no, yeah, 3 or 4, right? And so once I did that, right, I went ahead and shot that up to the root so it knows about this change, right? Went and sent some messages out, right? And it's sending it. Now, what we're doing here, and all these messages look the same, what switch 2 is doing is it's sending BPDUs out, right? Trying to listen to other switches, right? It's broadcasting itself, but it's also listening as well to see if there's any other switches, right, that want to, of course, join this topology, right? And hopefully we hear something, right? And so we're getting it. Oops, sorry. There we go, right? And we didn't hear nothing, right? So all of those timers expired as far as the BPD, right? But we're still sending it, okay? But we see here is when we go ahead and we connect, right? We connected to switch 3, right? And so once we finally have a connection to switch 3, now we're talking, right? We're transmitting a proposal like, hey, here's my bridge ID, right? And here's my information about my spanning tree, okay? All right. And of course, switch 3 is doing the same thing. It's letting every switch know, anything that connected to it, know that, hey, here's my BPDU, here's my information about my topology from my point of view, okay? Then, right, so that tiebreaker is happening in the background, right? They're doing this computation on their own switches. They're not doing these computations together. They're doing it on their own box, right? They're just sending that information to each other to do the computations, right? Then we see tiebreaker has been selected, right? That's when we see a dispute has been resolved, right? So that tiebreaker is not happening anymore, right? It took roughly what, 4 milliseconds, right? That tiebreaker has been completed, right? And we see gigabit 0/1 has been changed to a state of being up, right? So layer 1 and layer 2, right, are showing up, right? And that's what we can see, right? Gigabit 0/1 forwarding state, right? So that, right? And this is what I mean as far as getting into the nitty-gritty and actually being a CCNA candidate. You have to dig deep and investigate how things work. The theory is one thing, but if you don't truly understand what's happening in the background, you are not going to fully conceptualize what is going on. Okay? All right. So with that being said, we're going to end it here today, and this completes your rapid spanning tree section, right? If there is something that I didn't cover, something that doesn't make sense after you guys reading, and I implore you guys to read, feel free to shoot me a message. We can have a quick lab and a quick theory talk about it, because I do miss some things. But yeah, we're going to close up in our next session that we do have, rapid spanning tree. We're going to go ahead and talk about ether channel, right, and how it relates to spanning tree. We're going to go ahead and talk about port fast, and we're going to talk about BPDU guard. A lot of environments utilize BPDU guard. So we just need to talk about that, right? And then we're going to go ahead and close out chapter 9. You guys have a great day. Thanks for joining.